welcome you all and thank you for taking part in this webinar we organized today. You know that this webinar has been organized in order to share with you what is the impact of a regional innovative network in the enhancing of innovation and of the digital transformation in the regional ecosystem of the Veneto region. Well, as you know, today we'll talk about Internet of Things and Industrial Internet of Things. During this webinar, the presentations and the speeches will be recorded, so then you will have the chance to re-hear something more or see again some video or PowerPoint presentations you found more interesting. Today, as you can see, we'll have our webinar divided into two sessions. The first one will be focused on the context. What does it mean? First of all, we'll talk about the European cooperation project in which the HIPA Innovation Hub, which is the organizer of this webinar and which is a digital innovation hub in the Veneto region, it's a hub that is involved in two European cooperation projects who focus on IoT and industrial IoT from different kind of issues. On one side, there is the attention to the smart specialization strategies, and on the other side, there is the attention educational and lifelong learning in the field of IoT, and which is the potential for the professionals in the market with this kind of competencies. Then we go through the presentation of the regional innovative network named ImproveNet. ImproveNet is a network that ICT for manufacturing processes Veneto network. This is a network that has been requested or at least it was a wish of the Veneto region in the field of the smart specialization strategies. This network is made of manufacturing companies and service provider companies, and about the network and the goals and the activities and the results will tell us Alessandro Beghi. Alessandro Beghi is a full professor at the Department of Information Engineering of University of Padua. He is used to manage several scientific international cooperation. We talk about industrial cooperation as well as cooperation with small and medium enterprises. He's author of different international patents, and he is the scientific coordinator of the ImproveNet network. Then we'll go through, we'll move from theory to practice. So we'll talk about the projects of ImproveNet, what has been done and what is the power of an innovative regional network and how this power can have an impact on the market too. So we'll talk about two projects. The first one will be Pre-Money, and we'll talk about the quality forecasting and intelligent maintenance in order to improve and optimize digital manufacturing solutions. The speaker will be the professor Gian Antonio Susto. He is also a professor of the Department of Information Engineering of University of Padua. And he's also a co-founder of the Stacked-Wolf company, which developed customizable data science platform and a dashboard in order to use cutting-edge machine learning and data visualization algorithms. Then we'll talk about additive manufacturing with an admin for the projects. And here we'll have two speakers in order to talk about two steps of the project. The first, research and innovation, and second one about the application of the project to the market. So Stefano Vitturi from the National Research Center, CNR, who is a researcher and who developed researches in the field of industrial communication networks in the last years about performance analysis and about the implementation of field-bus interfaces for devices like sensors and actuators. Will talk us about the research steps, and then Andrea Beretta will talk us about two case studies and will tell us about the strategies adopted and what happened providing the innovation to the market. Andrea Beretta is the managing director of Desamanera. Desamanera is an innovative startup that deals with additive manufacturing with materials deriving, for example, from stones, and they work with it despite the dimension of what has to be realized. So then at the end, you will have more or less 15 minutes for questions and answers. We'll invite you all to write on the chat your questions in order to provide you the answers, and then the closing time will be at noon. So it's time now to start. We'll start with the presentations of what ECIPA is doing, the ECIPA Hub, and mainly what are the projects in which in the field of which the project is organized. Well, first of all, let me introduce myself. I am Simona Ceto. I'm part of the Business Innovation Unit of ECIPA. As I told you before, ECIPA is a digital innovation hub in the Veneto region for the Regional Confederation of Small and Medium Enterprises. The S3 Hubs in Central Europe projects, I know it's hard to name the name of this project, but it is because it's concentrated in the title, because S3 are the smart specialization strategies. Hubs is for the digital innovation hubs. In CE, it's Central Europe. The goal of the project are, of course, to enlarge the potential of innovation, and in this way to demonstrate as much as possible how the cooperation among digital innovation hubs all around Central Europe and Northeast Europe, the international cooperation among digital innovation hubs and national authorities and companies can provide innovation really close to the market. So that's why the project is focused mainly in digital transformation and has selected some main technology domains. Namely, as you can see, the project is focused on data analytics and artificial intelligence, on factory and process automation, industrial IoT, advanced materials, machinery, and so on and so on. Then the final results of the project that we want to achieve will be the creation of an international platform for international knowledge exchange, pilot actions that can demonstrate that how this kind of cooperation can work, an international investment forum in which we'll share some champions of this innovation. These champions will be research centers, companies, universities, business support organizations who will be able to show how the digital transformation can have an impact at regional level. And then, of course, like every European cooperation projects, we expect to provide recommendations to the regional authorities. Just to show some partners of the project, as you can see, we have partners in Germany, Austria, in Italy, in Slovenia, and in Croatia. There are different kinds of partners. There are business support organizations, there are university, technological centers, service providers, and so on and so on. You can find more details about our website. Now it's time to introduce the other project added for Journey that will be presented by my colleague Laura Castellan. So I give you the floor, Laura, and you can present Talent Journey.
Yes. Thank you very much, Simona. So I will take just a few minutes to say a few words about Talent Journey project, of which we actually are a partner. As you can see, this project is co-founded by the Erasmus Plus program. And in fact, it is one of the first 5 Centers of Vocational Excellence pilot projects in Europe. Centers of Vocational Excellence, as per their definition given by the European Union, they bring together a wide range of players, not only vet providers, but also, for example, companies, research centers, development agencies, and many other players, in order to develop skills ecosystems that contribute to economic and social development, but also to innovation and smart specialization strategies. And their goal is to provide high quality vocational skills to support entrepreneurial activities, to spread innovation, and also to act as hubs for knowledge and innovation, especially for SMEs. So I think that the connection and the links between initiatives such as S3 hubs in Central Europe and the Centers of Vocational Excellence is quite evident, and also how they can be mutually beneficial. In particular, Talent Journey platform, as you can see from the slide, is the Centers of Vocational Excellence for IoT in Smart Manufacturing. And its goal is to provide top skills within the IoT field using innovative and user-centered pedagogical approaches. And I would like to stress very much the fact that we aim for the solution of the project to be very user-centered and very user-friendly. The main project outputs are a sustainable data collection on skills needs in the field of connectivity devices and services in IoT and smart manufacturing. We are developing a joint transnational curriculum and developing and training and testing also trainings for professional development. And then the designing of an EU and regional stakeholder ecosystem. Simona, if you can go to the next slide, please.
Sure.
Thank you. Because the goal of the project is that of innovating and improving the responsiveness of vet providers to the needs of Industry 4.0 and to the needs of new era society as well. And we have this very challenging ambition of becoming an example for the excellence in IoT field. You can see here in the slide the composition of the partnership. We have got partners from Slovenia, from Finland, from Estonia, from Germany, and from Italy as well. So as I said before, it is in the nature of Centers of Vocational Excellence to have a great variety of partners, and you can see also here in the partnership of Talent Journey. That's all from my part. I would like just to personally thank the partners from Talent Journey and from S3 Apps in CE as well, who are attending the webinar today. Thank you very much.
Thank you, Laura. So now it's time to go to the core of the successful case of our regional innovative network. And I can now give the floor to Alessandro Beghi, who will introduce us the improvement.
Well, thank you, Simona. Thank you for the invitation, and good morning to everybody. I'll try to share my screen so I can start my presentation.
It is working.
Okay, so let's see if I can put it in full screen. Okay, so I'm here as a representative of one of these reti innovative regionali, regional clusters. And the Veneto region decided a few years ago to go toward a different model of cooperative networks with respect to the ones that were in place before, that were mainly based on the idea of an industrial district. So geographically and thematically contiguous set of companies working exactly on the same thing, and with needs that were also common because of this geographical contiguity. I would say that the idea of industrial district is, of course, is a good one. Is not an idea that was typical of the Veneto region only, but somehow it ended up being not that effective in terms of cooperation, because many actors having the same market and working with very close competitors sometimes was harder than seeking for cooperation elsewhere. So the idea of the Regione Veneto was to try to change this kind of cooperative networks by focusing on thematics rather than physical contiguity and let's say identity of markets. So there are two keywords in Rete Innovativa Regionale that I would like to spend a few minutes on, and it is innovative, and regional. You probably know that Veneto is part of one of the most industrialized areas of Italy. There was the so-called industrial triangle, with Lombardia, Piemonte, and the Veneto and Friuli and Trentino regions have always been considered at the heart of the industrial production system of Italy. But somehow Veneto has always had the reputation of having built its success on hard work. The Veneto before the Second World War was mostly an agricultural economy. So, people used to hard work, really hard work, and very motivated to improve the overall say conditions of our social identity. And so for many years, Veneto has never been associated with the idea of innovation. And indeed, it is not like this, because I would like to show you, this is the output of a study that a colleague from the Department of Economics performed a few years ago. So forgive me if the data are a bit back in the past, but you need time to make up statistics. So Veneto has a very successful network of university, and among them, the University of Padua is the largest one. So I'm not naming Padua because it's my own university, but it is one of the largest in Italy. We have 60,000 students average per year. And the interesting thing is that over 10 years, of the 119,000 graduates from the university, 3% of them started their own business. So there is an entrepreneurial push that comes from the innovation that is brought by university. And this means more than 6,000 companies were built by graduates, 72% of which were based in Veneto. So there are many seeds of innovation that are brought on by our students. And of course, you cannot innovate, you cannot build your company if there is not a fertile grounds for doing that. And this is also something that is typical to Veneto. There is a curiosity for new things, and it is not that difficult to find opportunities to set up new entrepreneurial activities. So it is not true that Veneto is not voting to innovation. The second thing regarding innovation, I personally think that we owe a lot to the European Union, not only because it's, they're essentially, the EU is hosting us today, but for many reasons, I'm very grateful to this network of countries. But one reason for being grateful is the amount of statistics that they produce. And this is an output for the regional innovation scoreboard of 3 years ago that essentially help us to place regions inside countries and inside Europe as far as the innovation capabilities are concerned. So this is the typical spider graph where you have the dotted line represented 100%, so the average in the Italian context for the, I guess, something like red line. I'm colorblind, so I apologize if I say the name of the colors wrong. And relative to the EU for the blue line. And this is for the Veneto case. And as you can see, we actually perform much better than the average, both at European and at Italian level for, you see, design applications, trademark application, EPO patent applications. So there is innovation. We have many companies, SMEs innovating in-house. There a lot of product process innovation. So interesting also to see that if compared to the European average, we also have a large number of highly cited scientific publications. Once again, the quality of the academic research that is performed in the region is very high. So you see all of these axes concern innovation, but then we see that there are areas where we really perform badly. Innovative SMEs collaborating, public-private co-publications, R&D expenditures in both the public and the business sector. So this is telling us that there is a lot of potential, but somehow we are not capable of putting all of that potential on the ground because there are two aspects that definitely have to be improved. Collaborations among different actors, public and private to private, and expenditures. Of course, there is no innovation that comes from free. And I like to quote this line from the report that says that innovators and intellectual assets are the strongest innovation dimensions for the Veneto region, but the human resources, the finance and support are the weakest ones. So this is exactly the motivation that led us, the Veneto region, to start a new framework of cooperation. And of course, there is the commitment of the public actor to invest, so to turn some of the funding that come both from Europe, many projects that we have been working on in this kind of cooperation have been funded by the regional collaborative initiatives at the European level, but also, of course, the funding that comes from the the public money that comes from taxation. So to invest money to try to foster this kind of innovation, but the other dimension that really needs to be enhanced is that of cooperation. There clearly is one aspect that is sort of a problem in terms of cooperation, and it is that of dimensions. But it is one. You know that Veneto region has a very large number of companies, but many of them are very, very small. This is typically a problem when you talk about the research and development, because the dimension is typically a barrier, because to really do non-incremental innovation, you need to have resources dedicated to something that is not going to the market tomorrow. And the smaller the dimension, the more difficult it is to find this kind of quality time for doing innovation. But this slide tells us something that is valid for all over Europe, because these are the numbers at European level. So the problem of having a very large number of micro, small, medium enterprises is typical of all over Europe. So the tentative, the attempt to find ways to make SMEs collaborate for enhancing their innovation performance is something that may impact all over Europe. It is not only an Italian or a Veneto problem that of dimension. So I would say that this picture should help us understand the kind of effort that we started putting in these new kind of regional networks. We need to find ways to have more companies working together, particularly small companies. We have to find ways to have more R&D expenditures at both public and private sector to let that very big innovation potential that exists in the territory bloom and really be something that may help us to compete better in a more and more global market. Let's say that it's in all of the possible areas of impact, the global dimension is nowadays one of the most important topics to be dealt with. Okay, so again, this is the background. We have something more than 50,000 companies in the manufacturing system in Veneto. So that's about 10% of the overall national total. It is quite a traditional sector where most of the production is focused on producing machineries. So we, in the last years, have been, of course, very largely impacted by the Industry 4.0 revolution because most of the machines that are now produced have to be somehow Industry 4.0 grade to be introduced in innovative production lines. We have, a quite limited number of large enterprises. So some of them are really big players in the market, and they have R&D located here in Veneto. Many companies have are owned by international players who decided to keep the R&D in Veneto because of the quality of the environment. So access to university education and university collaboration, and also, the human resources are considered to be very good. So this is why R&D is kept often here in Veneto. What are the problems that we have seen in this new trend of associated with Industry 4.0? The first one is a skill shortage in the field of ICT. Industry 4.0 is a revolution that is led by ICT, so information and communication technologies. However, most of our companies, being very, let's say, traditional in their structure and typically being in the electromechanical field, have a very reduced number of operators in this area. And they're typically devoted to the management of the information technology architecture, which this is not the kind of skills we need if you really want to innovate in ICT. Okay. The transition to digital manufacturing then is something that is introducing a systemic view of the entire information content of the available data flow, from design and machinery level to aftermarket services. This is something really new for our companies. It is sort of a global vision of your assets, of the company assets that is not typically in the background of our entrepreneurs and also sometimes managers. And also the value of data and the value of this digital transformation is an intangible asset. It is typically largely underestimated. And to be capable of understanding the value of this asset and to find ways to exploit it really requires a highly innovative, multidisciplinary approach that is not, very commonly perceived in our industrial system. So I will not spend time on Industry 4.0. I would just say that ICT has impacted in our territory, typically in 4 areas. So use of data, computational power, connectivity, and all of the keywords that we know: big data, open data, IoT, machine-to-machine communication, cloud computing, so forth and so on. Analytics, so taking value from that huge amount of data. There is a lot of attention on HMIs because of course, the new machineries require a new approach to the use of the machines themselves. So HMI is important, in particular if we consider that our working force is not subject to a very fast change. So we have many operators that are, let's say, get older and older in the operation inside the company. So it is important to find ways to have the operators working in an efficient way with machines. And of course, the idea of linking the digital and real worlds by means of digital twin approach, so advanced simulation, so forth and so on. The kind of actors that are present in the territory is very heterogeneous, but all of the actors have to embark the same path to digital manufacturing. So the idea is to put together all of these actors and try to find best practices to identify technologies and methodologies that can indeed be applied to all of the different sectors. And the idea that now you have actors that do not necessarily fit in the same market, okay, so they have the same needs, but they are not direct competitors, is making collaboration easier, because once again, sometimes it is more difficult to cooperate with a direct competitor, although sometimes it is something that should be done to be capable of moving all of a sector toward an innovative path. Okay, so from a legal point of view, the regional network is an aggregation between businesses and public and private entities that are present in the regional area, but not in areas that are territorially contiguous. And these actors operate in innovative fields. There is no specific sector, but the idea is to fit the smart specialization strategy. So all of the partners have to be involved, in this case, in smart manufacturing activities. And the aim is to develop a set of initiatives and projects that are relevant to the regional economy, but are not necessarily limited to a specific production scope, as it was the case for regional districts, but are very open to multi-sectoriality. Okay, our aim is that to become a hub to collect and structure indication coming from the territory, so from the industry, but not only the industries, I would say, also all of the partners, academic partners, and institutional actors, and other clusters and at every level. The focus is on ICT methodologies, and try to find which methodologies can impact practices that are generalizable and applicable in different production sectors. These kind of innovation in the ICT is typically brought on by a collaboration of partners, so end users, manufacturing companies, service providers. There is research organizations, the innovation hubs. So we'd like to put all of these actors together and see what they can do when working in a cooperative approach. The ways by means of which we address this part are the typical ones, so research projects, training, dissemination activities, practices. And the idea is exactly to have a particular attention to SMEs that have less internal resources to devote to non-incremental innovation process. So this kind of innovation has to be done by using a different approach where service providers are strategic partners. They're not just providers of, let's say, solutions from off the shelf and sold by the companies, but there is a strategic partnership that helps to develop exactly what is needed. The idea is, as I said, to interconnect all of these actors, so create new models of collaboration. We would like to be a reference point in Veneto for the smart digital manufacturing, and the idea is to build up a critical mass that will help our company to have more visibility both at national and international level. there is a problem of visibility for our companies. This is something that has been going on for many, many years. We are strong, but we are not capable of showing outside how strong we are. As I said, we have production companies and service providers. In particular, we have many knowledge-intensive business services. Many of the companies I were quoting at the beginning, start up from our students, are knowledge-intensive business services in many areas. We managed to have all of the most important research players in the territory on board of the network. So the 4 universities in Padova, Verona, and the 2 universities in Venice. There is Veneto is the federation of the university in Veneto, so it says it is itself the network of the university, and of course the CNR, Stefano Vitturi, who will talk later, is a representative of the National Institute of Research. Just to give you, and of course I ask Simona to raise her hand when I'm talking too much and if I'm taking too much of the time. I just want to spend a few slides.
5 minutes, so
oh, perfect.
you're on time.
I think
okay.
That's great. I'm impressed by myself. So some players are big players. Electrolux is one of the largest companies we have. This is a picture from the production line in Porcia, so for the fabric care production line. And for instance, we see that this is the testing station that is being set up by one of the partners in the network. So we have tried to bring on board partners who already have some capability of collaborating together, so that the starting up is easier. But of course, the idea is to make more and more companies to collaborate with each other by looking at what other partners in different areas are doing. Okay, so this is one of the most important things. The needs are the same, ICT for manufacturing. But if you do that for production of a laundry machine, or for a weaving machine, this is a weaving machine by Smith, of course you have to do something which is different. And the idea is, let us leverage on the project that study methodologies, apply to different use cases. But the most important thing is that our entrepreneurs should see what is the effort needed to take methodologies to their own production reality. And the language we have to talk is that of entrepreneur. Okay, so this is why, as academics, we are very happy to be there. We have our, the aim is to give a technology forecast. But in the end, companies have to work together, and because they speak the same language, and it is easier for them to understand the return of the investment. So this is a coding system, once again, for in the textile production system. This is packaging, so the filling machine. This is the Zemanera, one of the machines Andrea Beretta and Stefano Vitturi will talk about later. So you see very different kind of production assets. We have a typical set of strategic objectives. So to do pilot projects, Premani and Admin for the, pardon me, are one of them. So are some example of a pilot project. We would like to have shared labs. We would like to have actions in continuous education. This is a very sensitive topic because of the aging of our working force. So, all of these objectives essentially aim at building up a critical mass, gaining visibility, and letting our partners to go outside to the regional boundaries. Okay, these are the technological trajectories, but these are the typical ones of Industry 4.0. So I don't want to spend much time on them. You will see all of the keywords that you see in all of the projects that concern Industry 4.0. Okay, so this is just a snapshot. It is not a complete list of companies. I just would like to point out that the managing board sees the Confindustria, which is the Federation of Industries at a regional level with the service company CIEV. We have a representative of a large, of a small and a medium-sized company, and of players in the innovation area, so the technology transfer company, T2I, and of course the Federation of the Universities. We have a bunch of academic partners and a number of companies, which is about 40, 50. It is increasing, you know, some of them are very active, some other need to be somehow pushed a bit more to get into this path. But we are very happy to see that our partners are alive and kicking. We have some interesting projects starting up next year, and I hope that we will have the time in a future occasion to also discuss them. I'm just ending up by pointing you to our website and our contacts, so feel free to send us a mail if you want to know about our network. We are always open to collaboration. And we believe we are an important player in Veneto, and we are sure that we can contribute to cooperative actions in a very successful manner. So thank you very much for your attention, and Simona, back to you.
Thank you, Alessandro. It was a very interesting overview about the positioning of the innovation of the Veneto region from the point of view of the industrial side on one sense, and from the point of view of the small and medium enterprises, because we never have to forget that the most part of companies are small and medium enterprises all around Europe. You mentioned a very key word, that is the collaboration, that it's also the big challenge we have to deal with in this moment, because you know you have to be so good at achieving the trust from your possible partners, and to convince them that the innovation and the way to innovation is made of cooperation too. It is also interesting that research and development is one of the strong points of the Veneto region. Of course, the region is not the best in class in all the issues you mentioned in your graph compared to Europe, or at least to the rest of Italy. But there are some strong points. One of these is the research and development. So as you have shown, ImproveNet is exploiting this added value of research and development of the Veneto region, thanks to the involvement of the 4 universities in the network. And is paying attention to the small and medium enterprises in order to support them and to show them that a service provider is not only a provider, but he or she, or at least the company, can be a strategic partner. So it's very important that you mentioned a service provider as a strategic partner for the innovation process. And of course, you also mentioned a keyword that we use so many times to mention when we talk in our projects, in our cooperation projects. We have to adopt the language. So this is something that the regional authorities too have to adopt and have to keep in mind. We have to change the language and to adopt a specific language in order to communicate with the economic system, with the companies. And we have also to adopt different languages if we talk with small companies and or with an industry. So thanks a lot, Alessandro, for all these insights. Now we can move from the insights and from all these interesting issues about the regional approach and about the pillars of a regional network. We can move to the practice. So we'll go through to one of the projects that the ImproveNet network implemented with the coordination of Gian Antonio Susto, who is a professor of University of Padua and co-founder of the Statworth company. He's working on data science mainly, and he will introduce the Pre-Money project. Gian Antonio, I will give you the floor. You can share your screen, or at least you can tell us about the Pre-Money project.
Sure. I think you are able to see my screen now. Am I right?
Yes, yes, we can see it.
Fantastic. Thank you very much for the introduction. So just a little correction. I will introduce the Pre-Money project. I was not the coordinator. Alessandro was the coordinator, but I was heavily involved. So I'm really happy to present the project to you. So as we were saying, I'm Gian Antonio Susto. I'm an assistant professor at University of Padua, and I'm working in the field of machine learning applied to Industry 4.0 application, and we will see a little bit about that later. I'm also the co-founder of Statworth, which is a startup providing cloud-based solution for the industrial IoT world, and we will see something about that as well. So it is a great pleasure for me today to present the Pre-Money project, which is one of the flagship collaborative projects in the area of smart manufacturing for the Veneto region. So first of all, what Pre-Money stands for? Pre-Money is an acronym that, with a little bit of creativity, let's say, comes from my project title that can be translated into English with design, development, and implementation of a digital manufacturing solution for intelligent maintenance and quality prediction. So long title, so we needed an acronym. So I want to spend a couple of words on the title. So our goal is to tackle the field which is really, really relevant for both SMEs and big enterprises that is related to quality and to maintenances. So in this project, we are aiming to provide a new solution, new tools that are based on the Industry 4.0 technologies, on data-driven technologies, for developing new solutions that are not off-the-shelf solution. There are ad hoc solutions provided for the use cases that we will see. And the interesting part of, and I think that the title summarizes it all, is that we care about the design, so our research and research perspective about these innovative technologies, the development, so high TRL, and the real implementation of such solutions. So this is a project that arrives to actually implementing things, to bring things on the shop floor or on the digital system that the companies are marketing after the finishing of this project. So Pre-Money is, before diving into the technical content, let me provide you some background information. So first of all, Pre-Money is a project of total cost of 5.4 million, and that sees a contribution of the Veneto region for 3 million euros. And the funding was granted at the end of 2017 for a 3-year project. So we are seeing we are in the final month of the project, so we are seeing the final goal. So it is a really optimal time to look back and to share what we achieved so far and what we aim to do after this. So the consortium has a little bit of overlapping with, of course, the partners of ImproveNet, but let me give you a little bit of background. So we have 3 types of entities that are fundamental, as we discussed before. They are equally fundamental to ensure that all of the phases, design, development, and deployment, are actually done in a proper way. So we have the universities. So we have the University of Padua that mainly was focused on machine learning and control system approaches. We have the University of Verona that was partially focused on machine learning as well, but with a different approach, which is the so-called digital twin approach. And we have T2E, which is basically mostly related to the aspect related to business, to market access, and to technology impact. Then we have use cases and users, which have provided us with case studies that I believe are paradigmatic for the type of maintenance and quality challenges that our approaches are aiming to tackle. So we have some companies that were already mentioned by Alessandro. So we have Electrolux, there is a producer of home appliances. In the context of this project, they provide us use cases related to the world of food preservations, so domestic refrigerators. Then we have several producers of equipment which have different type of challenges, and we will see about that. So we have Ciele, there is a small producer of machine tools, Galdi, that I will talk a little bit more about later, that produce machine for packaging, and we have Santex, the Santex Rimar Group, that provides a machine for the world of textile. And we have three foundries. So we have RDS Molding, Folderio Corra, and Folderio Zanaldi. And finally, we have an equipment producer, which is kind of the show the heterogeneity of the variety of the type of application that our approach can find place, since Sordato, the last end user, provide a HVAC system for the world of enology. And then I think the use cases where when the consortium will be set up, the interesting things about these use cases is that you can see there is a mixture of big enterprises like Electrolux and small medium enterprises, as we discussed before, and also a good mixture of equipment producer on one side and companies that do have their own lines, their own plant. Then finally, we have the third ingredient of our recipe. There are the solution providers that are fundamental to actually bring into action our own ideas that come from the university or ideas that come from such solution providers as well. But of course, since we are aiming to arrive to a deployment, we needed the solution providers for different type of aspects. So we have Statwolf working in the field of cloud and the solution for artificial intelligence. We have M3E, that is related to works in the field of mathematical models, IRS that provide measuring tools and systems, M31 that provide the embedded system and more, Enginesoft that provide the tools for simulation, Adalab, IoT systems and solution, and Synumerica works in the field of embedded digital twin and something more as well. So the companies come from two innovative regions. One is improvement that was well presented by Alessandro, that provided most of the partners. And then we have the collaboration with Symphonet. There is another network working in the field, another network from Veneto, always in the area of smart manufacturing, but is somehow vertical in the field of the foundry world. So such partners has basically provided us with many use cases. I've counted, hopefully I've done it properly, but I've counted 17 use cases. So projects that arrived to good results. So don't worry, I'm not gonna list them all, but I've chosen to share with you just two use cases in which for several reasons I choose these two, because they both allow me to are the one, of course, that I know better, so it was easier for myself to express and in case to reply if there are questions or more detailed questions about what was done in those projects. But the two projects beside that are paradigmatic, because one project will be related to SMA that works in the field that is an equipment producer. The other one is associated with a big company that has a line, is not an equipment producer, and the kind of paradigmatic of the kind of things that we have been working in Premani. So the first project is related to predictive maintenance, that in the context of smart manufacturing is what we call prognostic of a component or a subsystem of a complex machine or a complex process. So what is predictive maintenance? Predictive maintenance is basically one approach to deal with maintenance intervention that try to overcome the issues of the typical approaches. The typical approaches to dealing with maintenance are, let's say that the simplest approach is the so-called run to failure, where operators don't act on a machine until something is actually broken, which is a reasonable approach in many cases, but when you're dealing with complex scenarios where you need to deliver a certain amount of products to respect a production plan, you don't want to end up unexpectedly in a situation when one of your machine or one of your line is not working anymore. So that's the reason why, for example, we do periodic maintenance on our cars or stuff like that, in order not to find ourselves with the car broken in the middle of the street in the 15th of August or something like that. So that's the reason why for scheduled or so-called preventive maintenance in complex and critical operation are finding our best practice that is adopted in many environments. The idea of preventive maintenance is to exploit the fact that we know that particular failures, particular break-ins on a component or a subsystem happen like once every 3 weeks or once every 1,000 product produced, something like that. So the idea of preventive maintenance is to use this sort of basic statistics and to exploit such statistics in order to prevent the fact that an unexpected break is going to happen. Unfortunately, this is associated with the high cost, because doing maintenance is a costly operation for many perspectives. Typically, it is not the cost of the spare part of the replacement. Typically, it's the cost of having your production line stop because you are doing a maintenance intervention, or the cost of the operators that are actually employed in doing such intervention. The idea of predictive maintenance is by exploiting typically data-driven approaches, so artificial intelligence and machine learning, is to exploit additional information that we have on our system in order to do the maintenance just when necessary. So optimizing a trade-off between unexpected breaks on one side and unexploited lifetime of the equipment or the system on the other side. And the impact of this kind of technology, of course, we are introducing a complexity because we need a more complex intelligence system to deal with the planning in this case, and to support the maintenance of operators or the plant manager in order to schedule the maintenance. We are introducing a complexity, but on the other side is a so-called high risk, high gain technology, because we can reduce the waste and the defective products, we can increase the uptime and the productivity, and also we can optimize the handling and the usage of human resources involved in the maintenance. So predictive maintenance is really catchy, and this particularly interesting for equipment producer, because equipment producer, they do need to know things in advance, because in the case, for example, Galdi, which is the use cases that I will talk about in the next 2 slides, there is a producer of machine for packaging of dairy products, so milk, but also orange juice, perishable products. They have their own machine that are installed everywhere in the world. So typically they need to be the one doing the maintenance, because the machine are quite complex, so they need specialized technicians. So typically what happens is that people from Treviso, where the company is placed, needs to take a plane and to go around the world in order to fix this kind of machine. So if they have an advantage in knowing like 2 days in advance or 3 days in advance or even more that they need to perform a maintenance, they have a concrete advantage, which is related to the logistics. So predictive maintenance is also really important for people owning a plant or a line, but the logistic there is less complex. So for the advantage that you get for if you are an equipment producer are much higher in this case, especially if you have like a Galdi case, if you're dealing with perishable products. So if the milk, of course, has to be packed in the packaging in a certain amount of hours. Otherwise, you have to throw away the product, of course, because the product cannot be kept there for 1 day or 2 days. So it is really fundamental in this case where you're throwing away products to be able to have your machine that respect a certain uptime and is able to run when it is required. So what we need in order to do predictive maintenance, which sounds really nice, we need several things. So we need, on one side, we need historical data. So this is like something that we typically need in the context of machine learning and artificial intelligence. We need to see what happened in the past. If we know what happened in the past, then we know we have a way to see a phenomena that we want to predict and describe and be able to do forecasts in the future. So we need historical data. And not only data that tells me, okay, this machine breaks down.
We lost Gian Antonio.
I think it's me.
Gian Antonio, can you repeat? Because I think we lost you for a while.
Do you hear me now?
Yes, now we can hear you.
Okay, when you lost me, you lost me here in this slide or before?
In this slide.
In this slide.
Okay, so it wasn't. Okay.
So you were talking about the artificial intelligence model, or?
Yeah, exactly. So I was listing a little bit of things that we need if we want to develop a predictive maintenance solution. So on one side, we need historical data. So we need to see in the past the breaking of a component of our equipment, something like that. But we just don't need to see when it did happen. We need to have additional information. So typically hidden in the data, in the sensors that are already in place on the machine, there are a lot of information, a lot of readings like pressures, temperatures, and whatever makes sense on that machine that if combined together, provide us additional information that we can exploit to somehow define a state of a machine, that it is a sort of hidden state of that machine. And on that hidden state, we can construct an artificial intelligence model that allow us to provide prediction in the future on when a break-in is gonna happen. So we need this kind of data, or we need an artificial intelligence model. That is the one that we have we have developed many artificial intelligence models during the project, and we need to have a connection, of course, with the machine. So in this case, cloud infrastructure and IoT connection to those machines is necessary because we need to see these readings in the future on machines that are currently installed around the world in order to give back to the maintenance operator and the people dealing with the service and after sales, the information on when they need to act. Then, of course, we need a platform for updating the model, because the concept of artificial intelligence is that if we have more data, we can do our model better. And the interesting part of artificial intelligence is that you don't need us anymore. Once we know a structure of a model, the model by itself is able to update and improve with the availability of more data. And then, of course, we need also a support decision system for operators. So they need to, the humans need to consume the information in a sort of user-friendly way that can be embedded in their own IT system. So what are the results of the collaboration with the Galdi? So we develop models that are able to predict the performances, the productive performances of some machines. We had models predicting the failures related to mechanical movement component. There is a sort of subsystem that is present on all of their machines. When their machines are not standard machines, but there is a quite high variability in the machines that they produce, and they are now offering, predictive failure services to their own end user, which I think are great results, and I think they represent a good success case for our Per Money project. So the second case, which is somehow related to the first one, so predictive maintenance aim at doing prognostics, so a predictive stuff that will happen in the future. The other side of the coin is the so-called anomaly fault detection models. They're aiming to do diagnostics, so try to understand better what is already happening on the machine, which sounds a little bit a trivial problem if you compare it with doing prediction in the future. Knowing something that is already happening sounds trivial. Well, it is not, because if you're dealing with a complex system, most of the time there are a lot of things that with the traditional way of monitoring machines or processes, which is the control chart based approach, the statistical process control based approach, which means I look at some KPIs. If that KPIs is within some limit, I'm fine, and I do nothing about it. But typically, when you're dealing with complex problems, these sort of approaches that takes a look at one variable at a time are not really effective, and many things that looks strange, if you take a look in a proper way at the data, they go completely undetected. So in the direction of following the zero defect paradigm, we try to introduce something more that is complementary to what we can do with control-based approaches, that is called anomaly detection. Anomaly detection approaches aims at finding strange things in the data that may be associated with defective product, with machines that is not performing as it is supposed to be. And we are aiming to provide these sort of approaches that are really nice, because are probably the most plug and play things that can be done in the context of machine learning applied to manufacturing. They can deal high dimensionality. So if we have a machine with 100 sensor, we have one single model that is able to consider them all at the same times. And they are able to deal also with what I call complex data distribution, which is typically what happens in the real world scenarios, where you, on a singular machine, you are running several recipes, you are dealing with different products, you have a lot of complexity, and such complexity typically is not well tackled when using classical approaches. So in this case, I'm showing you a big enterprise, a use case that I'm with Electrolux. So in this case, we are in the context of the production of refrigerators. And in particular, we have been dealing with a process, which is the vacuum process, which is the process of creating a vacuum in the machines between putting the refrigerant liquid. It is a really critical process, because if it's not done properly, the refrigerator is going to be really noisy, and when installed in the home, in the houses of the people, it produces that kind of noise, which is some frequency that are really annoying. So that is one of the things that quality don't want to happen, because it's one of the things that make people not buying Electrolux anymore. So we are dealing with a problem with a process that is really complex, and on the other side, it's kind of difficult to be monitored, because in here you have a lot of heterogeneity. You have different machines, different pumps doing the same vacuum process. So there is a little bit of complexity. There is the scenario that I was describing before. In this context, we develop also in this case an artificial intelligence-based anomaly detection solution that is implemented in a support decision system. A support decision system that is this one. So basically, they allow users to have an overview of what is happening on the line, to see how many anomalies am I doing in one line, and to be able with some pinpoint and drill down to go back and to trace back which are the problems. So this is a sort of overview for, say, analysts in some sense, but this artificial intelligence is also interrogable, so it's also can be called also by automatic system. And now we are one of the follow-up of the project will be to move from an analyst point of view perspective to on the field automatic implementation and action associated with anomaly detection. So in both two cases, I stay on a really high level of complexity. On the other side, the interesting part of this project is that on one side, we were able to achieve some results that are really important results for the company on the other side, but there was even room to do research because the use cases that we had there allow us to came out with some algorithmic solutions that are completely new. So if you are interested in going into more details, we have already 4 scientific papers that have been published on conferences and journals. These are already published. I think there are 3 or 4 more out there under review. One really interesting thing that is really difficult to achieve in the context of smart manufacturing, we deliver also a public data set coming from the packaging use cases that I was telling you before, which is really important in my perspective, because in the context of industrial development of artificial intelligence solution, there are really, really few open and real data set for confidentiality reasons and whatever. But I think there are a really important aspect of the collaboration in Primary project was to be able to involve also companies in a way to think about open innovation and to see the value of opening also their own data, their own problem, because maybe someone else can come out with a better solution with the one that we achieved, and everybody wins in some sense. Other infos are available on the ImproveNet website that Alessandro was talking about before. Of course, given the focus of this is a regional project, and most of the infos are Italian, but nevertheless, feel free to contact myself this email or to contact Alessandro with more information. Of course, if you have questions after Andreas and Stefano talk, feel free to ask, but even if you have some follow-ups, feel free to ask about. We will be really happy to speak about the Primary project more in details. Thank you very much.
Thank you, Gian Antonio. Thank you very much. You were perfectly on time. So it was really interesting to see and to touch on how a kind of cooperation can work. On one side, we have seen there was a consortium of companies and technological provider. On the other side, the end users, and on the other side, the solution providers, the one that Alessandro named strategic partners for the innovation. And the interesting issue of this project is also that you involved 2 regional innovation network. So it was an additional challenge for you too. And this is a very innovative mindset in the team who managed the project, because you dealt with different persons, different organizations, and yes, if you are a project manager of this kind of projects, it's really hard to tune all the partners involved in the project and in order to achieve the final result. So it is very interesting. You mentioned that you developed 17 use cases, and you mentioned just 2 of all of this. It was very clear, your description of the case of predictive maintenance on one side, and on the other side, the fall detection. Of course, you mentioned some big company, but this kind of information can be, this kind of project, this kind of innovation can be applied also to a small real context too. And it was also interesting that you said that thanks to this project, we developed new algorithms. So you innovated on one side the the market, the processes in companies, and on the other side, you innovate your company to yourself, you as a service provider, because you developed an innovation in your own package of services, in your own competencies. So this is a real case on how complementary knowledge and competencies can drive to the innovation. Thank you, Gian Antonio. Thank you very much. Now we'll move to another project about the additive manufacturing. This time we'll have two speakers for the project. As I mentioned before, we'll have two speakers because we have Stefano Vitturi from the Research National Center, CNR, who will drive us through the research steps of the project, and then Andrea Beretta from the Desa Manera company, who will drive us through the the two practices of how this innovation has been provided to the market. So, Stefano, the floor is yours.
Well, good morning to everybody. I think you should hear me, and you should see the presentation. Is that okay?
Yes.
Yes.
Oh, thank you very much. Well, good morning to everybody. I am Stefano Vitturi, and I'm a researcher of the National Research Council of Italy. I would like to thank very much Simona and all the organizers for the opportunity. My presentation will provide some technical and scientific details about the admin for the project, and the presentation will be followed by another one by Dr. Andrea Beretta from Desa Manera, one of the partners of admin 4D, which will describe some interesting follow-up of this project from the industrial point of view. Okay, admin 4D stands for Additive Manufacturing and Industry 4.0 as Innovation Driver. Is a project funded by Regione del Veneto, and here are some administrative data. The project budget is about 1.8 million of euros, and the funding is 70%. The duration is 3 years and a half. It was expected to close at the end of October, but we decided to ask for an extension due to the unfortunate COVID issues. We have 7 partners. 3 of them are private companies, and 4 are academic or public research institutes. The list of partners is reported here. We have Desa Manera, that is the main partner actually. Then we have the University of Padova, Venice, the National Research Council of Italy, and T2I as academic public partners. And then we have, besides the Desa Manera, we have Data Veneta Computers, supported by Statwolf and Mass Electronic. The project is actually based on the implementation of a 3D printer. It is a big printer based on a powder bed technique that is conceived to produce big artifacts, as you can see by the size of the printer. These artifacts are built using a mix of powder, powder which is often taken from recycled materials, or more in general natural materials like sands, water and natural reagent. So the basic idea is to build a 3D printer. But indeed, the project is much more than a 3D printer, in that it has been designed and built as an industrial Internet of Things ecosystem. And at the basis of this system, that we call demonstrator system, there is an idea of inserting sensors in the artifacts during their production. In this way, we can implement a real-time feedback during the production phase, and at the same time, we can monitor some variables, some data coming from the sensor after the artifacts have been deployed in their final positions. This system clearly requires the pervasive use of communication networks, since it is necessary to connect several system components. And by the way, the use of pervasive use of communication networks is at the base of communication, and heterogeneous networks, it is at the basis of industrial IoT systems. Which kind of sensor are we embedding? Mostly environmental sensors, but we are clearly, the project is open to every type of sensor. For the time being, we have used the temperature sensor, humidity and water saturation sensor, and some others. These sensors need to be equipped with wireless interfaces, since they have to transmit their measurements, their values from the internal of the artifacts to the acquisition systems. Sensors are then equipped with batteries that have necessarily to have a long lifetime, since we plan to collect the data for some years after the final deployment of the artifacts. In this direction, we have already carried out several tests, and all these tests were actually encouraging, since we are confident that the sensor will have long lifetimes. In these photos, you can have a look of some steps of the embedding process of the sensors. We insert the sensor within a commercial small electrical box with a protection, an IP65 protection degree. And then we insert them in the artifacts when they are produced. And the last photos here show an example, an artifact we have dismantled actually after some days after sensors were embedded, to check their integrity. Okay, this is the the architecture of the Industrial Internet of Things system we use, we basically have an intranet which is necessary to connect the sensors to the automation system of the printer in such a way to implement the real-time feedback during the artifact production. At the same time, we need a connection to the internet, in this case, in order to transfer data from the sensors to a remote cloud, which will be then accessed by some authorized users for activities like for analysis activities that we will discuss briefly in the following. How is implemented the real-time feedback, and hence how is implemented, how the intranet is implemented. Basically, we selected the LoRaWAN wireless interface system, interface network, to as a network to connect the sensors to the intranet. LoRaWAN, LoRa stands for low rate and then low power wide area networks. These kind of networks are characterized by actually a very low power consumption and by the capability of cover large geographic areas. So sensors have LoRaWAN interfaces. The data from the sensor are collected by a LoRa gateway. The LoRa gateway is connected to the PLC, which handles the automation system of the 3D printer, and the PLC is then connected to the plant that is to the printer. Just to tell you, this intranet comprises three networks. The first one is the LoRa communication system, which connects sensor to the gateway. Then the gateway is connected to the PLC via Ethernet network, and the PLC is connected to the plant via real-time Ethernet network, which is called EtherCAT, another commercial, well-known commercial product. Once the artifacts have been built, they are positioned in their final positions. In this case, they are connected, the connection to the internet, in this case, is implemented via, again, a LoRa gateway. By the way, this one is likely different from this one. They are two gateways clearly of the same type, but this second one is located, placed close, let's say about tens of meters or even hundreds of meters. Anyway, it is close to the artifact. Then, via an internet connection, the data collected by the gateway are transferred to a remote cloud. In the remote cloud, and here you can see an example of representation of the data stored in the cloud. There will be data coming from the production phase, which will be likely filtered since during the production phase we collect several data. And then we will have data from the environment, data that are measured by the sensors. So we collect temperature, humidity, and other. And this data is used for possibly tuning forthcoming production. So we are monitoring the artifacts and the environment. So we will get interesting information about forthcoming production. We will have to correct and to tune the production, new production processes based on the practical experiences. As we said, we will carry out environmental monitoring and possibly predictive maintenance. So, how is the situation? How is the status of the project? The project is actually in a good shape, since we are building the printer. We have already printed with a different printer, actually, some artifacts that are equipped with the sensors. So all the components of the printer have been designed, implemented, and tested, and importantly, all the communication networks of the IoT system have been put into service, and we are confident that the project will be completed by April 2021. Finally, I would like to thank you for your attention, and I am obviously available to answer to your question. Thank you very much.
Thank you to you, Stefano. Thank you very much. In a way, I understood what you have explained, even if I'm not an engineer. So thank you very much for your
I really appreciate
for your clear explanation. At least I understood all the process and the function of the different steps. And it's interesting that you just shared with us a real industrial IoT ecosystem, how it can work, and how much is important to connect embedded sensors and to take into consideration all the communication networks with heterogeneous networks too. And it's interesting also that you have expected that there is a low power consumption. Then my question was also to Andrea Beretta, but then we'll keep all the questions at the end of the speeches. It was how do you expect to maintain the sensor inside the innovation you are providing, because it's part of the material you are manufacturing. But then we'll go in depth during the questions and answer sessions. I don't want to stall in time to Andrea Beretta. So Andrea Beretta from Desamanera will show us how this innovation has been applied to practices thanks to the involvement of his own company. Andrea, the floor is yours.
Thank you, Simona. Do you hear me? Yes, okay. I'm Andrea Beretta. I'm ICT manager of Desamanera company, and today I talk about the opportunity that my company have from the admin for the project. Okay, Desamanera is an innovative startup born 6 years ago in Rovigo, Italy, for research and development of 3D printing technology of stone in large dimensions. Our core business is a construction and sales of the printers, 3D printers, develop natural binders and sustainable production processes, and realize a high quality of surface finishes. We produce the machines. We have a service of 3D printing stone. We here an example of surface finishes in marble skin, and our market is the world. And the areas where we have operated is arts, designs, architectural, engineering, cost protection, and heritage at the moment. For 3D printing, Media Network put us in the one of the 7 company to produce binder jetting printers in the world. We have collaborated in many projects financed, 3 European projects, 1 in Italy and Admin4D with ImproveNet in the Veneto renovations. Here is an over fair where the BAM stand is exposed and used our technology. And now I go to show you a little bit video of cartoon to explain what Stefano has said in scientific words. I show a little bit video. Okay. This is our technology. With informatic data and big data transmission and sensor, the idea is that to insert in the manufacturer product the sensors. We can use the waste of the marble caves or other non-organic component, reduce it in powder, study this kind of powder, and realize the better sensor and the better binder for realize the model, the 3D model desired. All process in this moment as send data to the machine, and we can collect this data at the moment of the production and in the life, in the whole cycle life of the manufacturer. These data are collected in our cloud, and for the whole cycle of lives of the manufacturing, we can analyze and take the better choice for monitoring and resolve the problem of the nature or the city or the smart city and so on. Okay. I hope to be clearly. This is the board of the project Admin4D. I don't stay here because Stefano has said it already of this. This is the first 2 sensored objects printed in 2019 with a sensor inside. The sensor is completely separated for ambient, and this is a choice, a specific choice of the project, not arrive to the sensors. To speak about opportunities, the first opportunities for my company is the material sensors. Material sensor is an idea to change the change of the normal monitoring of the walls humidity using an original piece of brick crushed into powder. Realize a sensor integrated with the original materials and put it directly in the wall. So to have an interface of the same materials for improve the exchange of the humidity of the every other kind of data we want to collect. Here, the first laboratory test of the sensor material, where we have drop every 60 seconds in a bed of sands and brick, and over the brick, the sensor, water. We see the sensor in the initial states after 80 hours, after 33 hours, and after 28 hours, the humidity is completely passed only for contact to the sensors. We have stopped the drops now, and after other 10 hours, the sensor appear like the initial states. The important thing is to see in data this process. And this graph show you exactly the moment and the time of the experiments in the sensor, where you can see the temperature, electrical conductivity, the electric permittivity, and water saturation of the experiment. This is very important to go on site to test the system with compare this collect the data with the traditional system to use today in the market. We have produced sensor, transmitters, and the gateway LoRa. All this is produced by the project being 4D. The second opportunity is named BioReef, and the BioReef is a project to recycle stabilization and implementation of marine biodiversity through the creation of bioreefs using the shells of mollusk. The project is developed with Cursa and University of Ferrara, and in the right you can see one of the three reefs that we have inserted in the sea to test this project. We have taken the shell waste, inerted the shell with a special process, and after we have transformed this in raw materials ready for printing. Here you can see sensors we have tested with the mollusk shells produced with our 3D printing technology. And here you can see the graph of the value collected by the sensor, but not in the life of cycle of life, but at the moment of the printed. So this data are used to PLC to perform better the printer and for the University of Padua to certificate the reactions if it's good or not. In the right of the graph, you can see the elements of the data, water saturation, temperature in the rest of the days after the printed day. Okay, I have finished. Thank you at all. For any questions, you can write me a mail to andrea.beretta@desamanera.com. And thank you.
Thank you very much, Andrea. It was very interesting to see what it can be done with material waste. In your company, you have an approach of from the circular economy, because you mentioned that, and you also mentioned this in your website. So I invite you all to visit the Zamanera website. They have a sustainable strategy in their own mission. And it was interesting to see how the material sensors can be used, and what is the kind of application you are providing to and proposing to the market on one side, and a case of BioReef, what can we do with waste? So it's really interesting. As I asked you yesterday, today too, I would like to ask to you and to Stefano, what did you expect about the maintenance of the sensors which are embedded in these materials? What happened? So you mentioned that you expected a long life, but what happens if something is wrong, or you have a fault detection, as mentioned before by Gian Antonio Susto? Did you expect a way for a predictive maintenance, or what happened?
Okay, I answer.
When the sensor is lost, clearly. But the idea is to embed more than one sensor. We can use a sort of backup, and as we discussed, actually the lifetime we expect is several years. I could say 3, 4, 5 years, and in that period we will be able to get enough information for the analysis, definitely. But actually,
today,
a fault on a sensor, the sensor is lost, definitely.
But today we are at the start of the path. And so we collect all data, many data, the more data is possible to analyze this data in a future, because this is a new technology. And so we study today the data of production. This is possible. And collect the data in the cycle of life of the manufacturers, for to study and to understand if this data can help us to maintenance of the pieces. Today is a design piece. Tomorrow, this is possible to be an house or a building or other kind of material.
Mm-hmm. Okay, thank you. I don't know if there are questions in the chat, because otherwise I have a question for Gian Antonio. So during your speech, you mentioned so many obstacles, so many partners in the project. I was wondering, who were your contacts in the company, for example, in the Electrolux company, which kind of profile, and what have been the main obstacles you faced during the implementation of the project in order to achieve the final result?
So typically, I think that for ourselves, but also for other partners, what we have on the other side on different companies are or quality manager or ET manager, because since especially with the equipment producer, on the other side, you are doing something that is going to be embedded or somehow called by some other system. So these are the two types of profile. I believe that in the cases where it was the first time that we were working with somebody, the main difficulty, but also the main interesting part is that we were the one looking at the data for the first time with a different perspective. And most of the time, and this is typically what happened, is that even if you are an expert on a particular process or whatever, you have some a priori knowledge that when you see the data, it's not there. I mean, it's partially is there, but you find other stuff. So most of the time, instead of be amazed by what we're able to do with machine learning, they were really amazed and focused on what was happening on their own data. So I think that this is one of the type of things that happens in all the projects. I mean, even outside of smart manufacturing, where one additional outcome is having someone with a different mindset and taking a look at what's happening in your processing through the lens of the data. On the other end, of course, the complexity is, and I think that all the solution provider help us a lot, is to even if we're used to work in application, speaking the language of someone on the other side is a sort of things that when you have some man in the middle, is much more effective for setting up the right targets on one side and for conveying the impact of what you're doing. So that's the typical scenario. I don't know if I answered your question, but this is what.
Yeah,
Okay.
you did. Yes, I was curious because, dealing with European cooperation projects, this is a kind of issue you have to deal with every day. And it was interesting to understand also what happened with a big company and if the kind of relationship and the project flows are similar to other contexts. So thank you, Gian Antonio, again. And I would like to ask Alessandro something about the next steps of ImproveNet. Which are your next plans? Which are, if you can spoiler us, your next projects, or which will be the focus of your next project?
Well, we have projects coming up. The evaluation process of the last call of regional project is going to be ended soon. We, as you know, we are living particular days. The pandemics have, impacted in many ways on our production assets, and the Veneto region asked us to start to focus on innovations that could also be, weapons to counteract some of the drawbacks caused by the pandemic. So our next project, if it will be financed, I hope it will be on remotization and virtualization methodologies for smart manufacturing, because we have seen in the present situation the access to assets, the actual production line or your machinery at the customers, or even just the access to your production plant may be endangered by unexpected phenomena. And this is one of the trends of Industry 4.0. So to make everything both in the digital world and then in the real world. So, virtualization. And of course, the more you can sensorize and analyze data from remote, the more you may expect your system to be working even if you're not there. So this is the focus of our next project. Hopefully it will start, if everything goes well, by the beginning of next year. I would just like to steal you one more minute, Simona, to comment on these two projects, because I think it's important for understanding what we want to do as a regional network. The first project, Premani, was sort of a top-down project where we identified some methodologies that we believed were common in many different production areas. And then we collected a number of companies who had never worked together, okay? And we started these many use cases to show that these common methodologies may have led to common results, even if declinated for the different areas. So this is the technology forecast we do. We recommend companies to start a given path. We work with them so that they can really, let's say, taste the innovation that is associated with these technologies. Admin4D was exactly the other kind of project where just the fact of being inside such a collaboration helped desa manera to individuate a number of strategic partners, and really for doing something that, you know, it is the innovation of the entrepreneur who decided to take a certain path. But then the availability of service providers and knowledge from the academic partners was really the enabling element to move the company toward such a, I would say, outstanding result. And the other thing, there's a follow-up, which is even better, because all of these projects should be pilot projects. We are not funding R&D for the companies. We are funding an innovation process at a regional level. So the fact that desa manera is still innovating, you know, leveraging on the output of the project is exactly what we would like to happen. So this is our idea of helping companies to do innovation in a cooperative approach.
So you answered also to my next question, that was, do you think that all these kind of projects can go on by themselves, so they can have they can go forward even once the cooperation within the ImproveNet network will be ended? And you answered yes, because desa manera is just a successful case of this kind of goals and tangible results that you achieved and that you expected to be achieved. So thank you very much, Alessandro.
You're welcome. Thank you all. Thank you again for hosting us.
Yeah, I see that there is a question here in the chat. Francesca Montresor asked, which could be the best advice for young students in order to face their work future? I think that the best advice in order to work in this field, because I hope this is the sense of the question. So I don't know if you or Gian Antonio who would like to answer the question.
Well, I have gray hair, so maybe. Well, my recommendation is to understand that this technological area is evolving at a pace that has never been seen before. So whatever kind of education you may think to build upon, please take into consideration the opportunity of continuous education. So, you know, to access this kind of market, we typically have a number of profiles that come from engineering, from computer science, data science. Gian Antonio is an example of an evolution of an engineer. You know, he's a control engineer, but who really became a data scientist for industrial applications. So my recommendation is build on something that is well established. So, you know, take your bachelor, take your master, and build the fundamentals. And then it cannot stop there, because the pace of evolution is fast, and you always have to keep an eye on what's going on. This is digital world, so many opportunities are in the digital world for keep learning. Many you know, webinars, programs that you can take on your own, with your own pace, and without resorting to, you know, standard programs just like MBAs and so forth and so on. The thing is, it is everything about information. Okay, so information technologies are information based, which is not, you know, just a way of saying. Information is a quantity that has to be analyzed by the right tools, so information theory. So I would recommend everyone to take at least a course on statistics, on analytics, on some mathematical tools that are necessary to understand information that is quantitatively described by, you know, in mathematical terms. This is very important. And then, you know, always keep an eye on the technological trends because you can never stand still in this field.
Yeah, it's a never-ending process. Yeah. Thank you very much, Alessandro. I don't see there are any other questions, but in any case, we are perfectly on time. It's noon. I'm happy we had our travel through successful cases. On one side, the Regional Innovation Network, on the other side, 2 projects we had as a speakers the different point of views, point of view of the university, the point of view of the researcher, the point of view of the company, and from a manager of the company. I think it has been a very fruitful webinar. In fact, we had more than 140 participants today from all over Europe. We touched 2 different projects, one with a top-down approach and the other one from a bottom-up approach. We have demonstrated how a regional innovation network can help a company to innovate, firstly with the cooperation of strategic partners, and then can go on directly by itself. So thanks a lot very much to Alessandro Beghi, to Gian Antonio Susto, Andrea Beretta, Stefano Vitturi, and to all the participants to this webinar. Thank you.
Thank you. See you soon.
Thank you. Bye-bye.
Thank you very much.
Everybody.
Bye.